Okay, hello Physical Science, this is Mr. B, and we are going to finish up section 1 today, again, focusing on thermal energy and matter. Again, temperature is a big thing that's associated with thermal energy. So again, temperature is going to be affected by thermal energy transferring from a hotter object to a colder object when we talk about temperature. So now another kind of big thing that goes along with thermal energy and with temperature is what is known as specific heat. So specific heat is going to be thing that associates with how temperature changes. So specific heat, for a definition, I would definitely write this down. Definitely write down this definition. Is the amount of heat needed to raise the temperature of 1 gram of material by 1 degree Celsius. And so right here, they kind of give an explanation about what that means, because the lower a material's specific heat, the more its temperature rises when a given amount of energy is absorbed by a given mass. So what that means is specific heat basically determines how susceptible you are to temperature change. If you have a low specific heat, that means your temperature is going to rise and fall much easier than something that has a higher specific heat. So that's my kind of best way to simplify what specific heat means. It's basically how susceptible, how easy it is for you to change temperatures. That is kind of my definition for specific heat. So some objects are really easily can raise and lower their temperature. Some objects kind of takes more energy to raise and lower their temperature, and it's kind of a big factor when determining what material you're going to use for different jobs. So kind of a real life example here is when a car is heated by the sun, the temperature of a metal door is going to increase more than the temperature of a plastic bumper. So because the temperature increases more in the door, that means that the iron in the door has a lower specific heat than the plastic in the bumper. Again, if your temperature is more easily affected by a change in the energy that's around you, that means you're going to have a lower specific heat. Again, the plastic, it doesn't get affected as much, so it has a higher specific heat. So here are just some specific heats of different materials, of water, of plastic, of air, of iron, and silver. And as you can see, the fact that water has a high specific heat, that is kind of just huge to our life on Earth, because if water was constantly changing temperatures all the time with all the dramatic temperature increases that happen in some areas, it would be hard for life to be sustainable here. So the fact that water can kind of resist too big of change in temperatures too soon. Again, eventually water will heat up and cool down if it's exposed to the same amount of temperature over a long period of time, but in general, water has a very high specific heat, so it is kind of less subject compared to something as iron and silver down here, as they're going to change temperature much more quickly. And we can actually have a formula for specific heat, and now they don't actually tell you what everything represents in this, so I'm going to tell you. So probably going to write this down. This will be to see maybe who actually listens to the video. So if you are listening to the video, Q is going to be heat required, or heat in joules, so that's going to be the Q right there. It's going to be how much heat is required. M is going to be mass. Specific heat is actually used in the letter C. And so, again, that's how much is required to change the temperature. And then the temperature change is delta T. So for the quiz, again, this will tell me who's listening and who's not. Heat is represented by Q. Mass is by M, as always. Specific heat is C, and the change in temperature is delta T. So we can actually calculate this out. So we can actually, and again, we'll do these in class, but I just want to show you kind of an example on here of calculating specific heat. So an iron skillet has a mass of 500 grams, that's our M. The specific heat of iron is 0.449, and that's joules per grams times degrees Celsius, because again, that's going to be changing the temperature there, because how much energy, joules per gram, the mass, will it raise a degree Celsius, the temperature there. And so how much heat must be absorbed to raise the skillet's temperature by 95 degrees Celsius. So we're going to first read what information are we given. So we know the mass of the iron is 500 grams. We know specific heat is going to be 0.449. And we know our delta T, our change in our temperature. Again, it said it wanted to increase it 95 degrees. So we know our delta T is 95 degrees. So now, what unknown are we trying to calculate, and what formula are we going to use? So the amount of heat that is needed, that's Q, so that's heat, is going to be represented by Q. And now we have Q equals M times C times, and then again this is called delta, that's a Greek symbol, delta T. And we're just going to plug in everything, so we take 500 times 0.449 times 95, and that gives us 21,375 joules of energy, because again heat is just a measure of energy because it's thermal energy. And we can they put this K, remember K stands for kilo. You notice they move the decimal point over 1, 2, 3 places, so then they rounded it, so it's 21.4 kilojoules or 21,375 joules. Again, sometimes they just do that to make the numbers a little bit more manageable. Then you look back, is your answer reasonable? And again, they just rounded off the data to give a quick estimate. And so this right here, they just rounded all the numbers up, and that's much more simple math here. It equaled 25 kilojoules when they rounded everything, and that's pretty close to 21.4, so their answer is reasonable. And so now, like always, we can have a little extra credit here, a couple extra credit problems you can solve. Again, just write these answers on your quiz. It says how much heat is needed to raise the temperature of 100 grams of water by 85 degrees Celsius, and I'm going to give you a hint. That chart had the list of all the different specific heats, so look up the specific heat of water, plug that in. Again, it's just multiplying out your answer there. So that's your first sample problem, and again, go back and look at that chart for the different specific heats. And then now we have how much heat is absorbed by a 750 gram iron skillet when its temperature raises from 25 degrees Celsius to 125 degrees Celsius. So again, it gives us our temperature change right here, our mass right here. Again, you need to just go look up the specific heat for iron, which is again on that chart as well. So again, all those are very solvable. Again, you just kind of have to calculate out a little bit more into that one to figure out what a couple of those unknowns are. And now our next one, in setting up an aquarium, so I'm kind of familiar with that, the heater transfers 1,200 kilojoules of heat, so that's going to be the amount of heat required, to 75,000 grams of water. What is the increase in the water's temperature? Again, you're going to have to rearrange this time because you're now solving for delta T. So again, go back, look up what the specific heat of water is. You can just rearrange your equation there, or just kind of solve for delta T. Just plug everything else in and solve for delta T. Our next one, again, I think there's going to be 5 examples here that you can work on. To release a diamond from its setting, so again, the fact like a diamond ring, the fact that it's held up there, that's what's called the setting of a ring. A jeweler heats 10-gram silver ring by adding 23.5 joules of heat. How much does the temperature of the silver increase? So again, go look up specific heat from silver, and just plug in. Now you're solving for delta T in that one as well. And then our last one, you're going to be solving for mass. It says what mass of water, so again water, remember, go look up the specific heat, will change the temperature by 3 degrees Celsius when 525 joules of heat is added to it. So again, now you're just solving for mass in that one. So those are our specific heat examples. And now to end this, there's actually an instrument that kind of helps measure specific heat by measuring changes in objects, and it's a hold on, give me a second. It is pronounced a calorimeter. That's about the best way I can think of it. A calorimeter is an instrument used to measure changes in thermal energy. So that's going to be directly related to a specific heat. So the lower a material's specific heat, the more its temperature rises when a given amount of energy is absorbed by a given mass. So according to the law of conservation of energy, the thermal energy released by a test sample is equal to the thermal energy absorbed by its surroundings. So if you set a hot pie out and it releases its heat, or the amount of heat that it releases is going to be equal to the amount of heat that the air absorbs, or the amount of thermal energy that the air absorbs. And the calorimeter is sealed to prevent thermal energy from escaping. So this is kind of what the tool looks like, the calorimeter. Again, it's used to measure specific heat or changes in temperatures, because again, samples are heated and placed in a calorimeter, and then the temperature changes is observed. So it's just a tool that is used to measure different temperature changes. And again, that's really directly associated with specific heat, because the lower specific heat you have, the more your temperature is going to change. So That's it for section 1. Let me know if you have any questions.